Welcome to our last day of third term. So today is going to be very, very basic in terms of notes. We're just going to do a couple of these practice problems from tables and word problems, and then I'm going to give you the rest of the time to do any additional work that you might need to get done for term 3. So these go back to what we studied last time, which was deciding whether something is linear, quadratic, or exponential, or nothing at all. So to recap, linear functions have a constant increase or decrease. It's just a constant change, and it looks like plus something over and over again. Quadratic functions, they have a constant second difference, which means that the first time you look at the differences, they're not going to be consistent. It's not going to add the same thing over and over again. But the second time you look at them, they'll be consistent. Exponential functions don't have a common difference in that they're not being added. The same thing's not being added over and over again. For exponential functions, you have a common multiplier. Another thing that I always look for with exponential functions are those crazy fractions. That's kind of a dead giveaway. Every once in a while, you'll get a table that really just has no pattern at all. It might not even be a function. So always remember that you do have an option for a neither, but use that extremely sparingly. So if you're feeling confident based off of last lessons, you do not need to wait for me during this time. You're welcome to pause the video. You can skip ahead, check your answers, see how you're doing. If you want me to do a couple first, I'm going to walk you through one of each type as a review, and then I want you to pause the video and try to do the others on your own. So the first one that we're going to do together is number 1, and we are trying to look for some patterns. And the first thing you want to check is your X pattern. You just want to make sure that it's consistent. So this is adding 1, -2 plus 1. Okay, so my X values are consistent, so nothing to worry about there. So let's look at our Y values. So what's happening as I go from 14 to 10? I'm decreasing by 4. 10 to 6, 10 minus 4 would get me 6. 6 minus 4 would get me 2. 2 minus 4 would get me -2 minus 4 minus 4. Because that is a consistent first difference, we know that this function is linear. We could even think back to a while ago, and we could write the equation for this function. Since it's linear, it would be y equals mx plus b, where b is the y-intercept, which would be 2, and m is your common difference, which would be -4. So your equation would be y equals -4x plus 2. So if you're looking for the challenge to really make sure that you understand what you're doing, I would challenge you to try and write the equation for each problem that we do. For linear and quadratic, don't try to write the exponential function. Okay, let's look at number 2. What do you notice? I notice a fraction to a very big increase. So is this going to be linear? Probably not. Is it going to be quadratic? Probably not. This is most likely going to be an exponential function just by visually inspecting it. And now let's prove it. So what would I have to multiply 1/2 by to get to 1? 1/2 times something equals 1. So I'm going to divide by 1/2 in order to figure out what that something is, and I end up with a common multiplier of 2. So let's check and see if that holds. 1 times 2 would give me 2. 2 times 2, 4. 4 times 2, 8, 8 times 2, 16. Okay, so the common multiplier here would be times 2. Let's do one more together. We're going to do number 3. So number 3, what is the difference between 21 and 12? Well, 21 minus 12 would give me, it's kind of late, so my brain's not super working, so I'm just double checking. Okay, that's 9. All right, so this is minus 9. Do the same thing there. 12 minus 5 would give me minus 7. That one's easy. Minus 5, minus 3, minus 1, and then, oh, here's a change in pattern. Now I'm going up 1. So one thing to notice right away is this is my turning point. So that means that this is going to be the vertex of some sort of function. So now let's check our second difference. Minus 2, minus 2, minus 2, minus 2, minus 2. So because the second row is consistent, this is an example of a quadratic function. And if you're looking for the challenge, let's review how you would write this equation. I'm going to switch colors so it doesn't blend too much. So remember the general equation is y equals, and then you would do x minus h squared plus k, and we already know that that point right there is our vertex. So y equals h, 2 would be h. So minus 2 squared plus, oops, it's a negative 4. So it wouldn't be plus k, it would be minus k. And there's our equation. So again, I challenge you to pause the video, do the rest on your own, try and write the equation if you can. So let's check our work. So number 4 was linear with a common difference of minus 3 consistently all the way down. Number 5 is also linear. Ooh, kind of ran out of room there. With the common difference of plus 5. Number 6 is an example of a cubic function. So this one's interesting because you have, I think, wait, hold on, now I'm second guessing myself. Yeah, it's a cubic function because this is negative 18 to 6, which would give you minus 12. Oh no, I'm sorry, plus 12. And then we have plus 4, plus 2, plus 2, plus 4, plus 12. And even the second row, okay, let's keep testing. We've got, what's the difference? How do I go from 12 to 4? That would be minus 8. And then minus 2, 0. This is not working out. I think I'm getting myself confused here. You know what? Don't even bother. It's not working. So this would be an example where you would say neither. In my notes, I have that this is a cubic, but you don't study those until secondary 3, so you know what? We're just not going to worry about it right now. Number 7 is an example of exponential. Some dead giveaways are how rapidly these numbers are increasing. Okay, number 8 is also exponential. By inspection, tiny fractions. Number 9 would be neither. It is almost perfectly a quadratic, except for this point right there that ruins it. Okay, it should be a 2, if this was a quadratic function, but it's not because that last point does not keep the pattern. Number 10 is linear. Number 11 is exponential. Again, look at those fractions. Number 12 is neither. 13 would be quadratic. 14 would also be quadratic. 15 quadratic, and 16 exponential. So if you're checking your work and one of those doesn't quite make sense, or now that you know what the answer is and you still can't figure out why it's working, this would be a perfect time to screenshot something, send me a email. Hey, say, Miss Smith, when you were doing this, I was really confused on number 11. Can you please go back and explain it? And I would be happy to do that. All right. The next section of notes, we're actually going to now convert this to word problems. How can you tell whether something is linear, quadratic, or exponential just from word problems? So there's 3 basic steps that you want to take. Step number 1 is to always make sure that it's a function to begin with. So remember, the definition of a function is each input has exactly one output. Okay, once you've determined it's a function, then you can determine whether it's linear, exponential, or quadratic, and then you can kind of describe the general growth pattern. So if we were to read this, a plumber charges a base fee. So a base fee means something that happens right away, of $55 for a service call plus $35 per hour for each hour during the service call. So the relationship between the total price of the service call and the number of hours worked. So if you're like me and you kind of have a hard time thinking about that, my best advice would be to create yourself a little table where X in this problem would be hours and Y would be money. So think about it. The plumber has not shown up to your house yet, but you've called them and you've made an appointment. So before they even show up, this appointment is costing you $55. That's the base fee. After 1 hour of work, it's going to be that $55 plus $35. If you go for 2 hours, you would take that 55 plus 35, which would equal $90. And then you would add another 35 to it. So already right there, are you seeing a common difference? So is this a function? Yes, because there's nothing, a 5-hour plumber visit is never going to cost the same as an 11-hour plumber visit. And what kind of function is it? Linear, because you have this constant rate of plus 35 for every additional hour. Okay. Number 2, looking at graphs. So this one should be a pretty obvious pattern for you now. We've studied these a lot. Okay, this is quadratic, this is a parabola. Let's review some of the key features of a parabola. Here's your vertex. So here the vertex would be 0, 5. Here are your x-intercepts. So do you see how these aren't exactly on -2 and +2? This was a common mistake on the test. Several of you put none just because your answer was not a whole number. This is not okay. If your answer is not a whole number, you find the x-intercepts by doing the quadratic formula. And that allows you to find the decimal, the exact decimal at which that line crosses the x-axis. Okay, our third graph, let's connect these dots. What kind of function would this be? It's a drastically decreasing graph, which gets down to a bunch of little fractions. Okay, so this one would be exponential. Okay, we've got one more to do. So the relationship between the speed of a car and the distance it takes to stop when traveling. So I've got a positive 10, plus 10, plus 10, plus 10, plus 10, plus 10. I don't have any repeating y values, so it is a function. So let's figure out what type of function. Okay, I would need to find the difference. So I'm going to do 36 minus 12.5. I get my calculator out. And I get a difference of 23.5. Okay, I'm going to do the same thing here. So I get 69.5 minus 36. And I get 33.5. Uh-oh. These are not the same difference. Okay, let's keep going. Maybe it's quadratic. Who knows? 114 minus 69.5. And I get 44.5. Okay, so since they're not a first common difference, we should check the second difference to make sure it's not quadratic. So 23.5 minus 33.5 would give me positive 10. But then 33.5 plus 10 would give me 43.5. So this one is actually plus 11. So not even the second differences are the same. So we would classify this as a neither function. Okay, it's not quadratic, it's not linear, and it's not exponential. Hopefully that was a good review for you with determining linear, quadratic, and exponential. So that's all I have for you today. We're gonna hold off on the rest of the unit until we come back for fourth term. We are going to be continuing Canvas classes in fourth term. So enjoy your spring break. Do all of your term 3 work. Email me if you have questions. Do the extra credit if you're looking for a little grade bump. And I really, really look forward to seeing you guys again. I miss you.